Here's an example of using the Manova procedure to analyze a repeated measures design. So the setup here is I have 3 groups of pigs here, and I've got 5 pigs in each group, and first we're going to give the pigs some sort of vitamin treatment. So if this is my timeline, say, here they get the treatment, and then at week 1 we're going to weigh them. So a week after they get this treatment, we'll weigh all of the pigs and get some numbers, those weighings, and then again at week 2 we're going to weigh them again and see if it had a different effect 2 weeks later, and then at week 3 and week 4 and all the way up to week 6. So we have 6 different measurements on the same pig. That's why it's a repeated measures. But it's not a crossover design because we're not giving 6 different treatments to these pigs and then weighing them again. We just give one treatment at the beginning of the experiment and then see how they do across time. So here's the data set, and these are the different weighings of the pigs. The treatment is control, low and high values of these vitamins. And then what we want to do is use the Manova procedure to analyze this. So the first thing, you have to state your class variables, like with any GLM. So treatment is obviously a class. And then my model is the weighings. All 6 of these weighings all the way across are going to be the response variable. And then treatment, which kind of vitamin they got, is the explanatory variable. We're using this no unit option over here to suppress the univariate results that it would spit out that we're not really interested in right now. The Manova statement is generally necessary. However, because we've got this repeated statement down here, it's kind of overkill. It's given us a lot of the same stuff, but I'll show you what it does. It gives us the general Wilks lambda and the other statistics that you're used to getting for Manova. And just so you know, the null hypothesis for this test is that these vectors mu1 through mu6, that is the average weight gain for week 1 through week 6 for the control group is equal to the vector for the group getting, this should be a 6, for the group getting the low vitamin level, and it's the same as the group getting the high vitamin level. So that's your null hypothesis, and the alternative is that these are not equal. So somebody is different from somebody else at one of the weeks, at any of the weeks. And then I'm doing this repeated statement down here. This is going to fit the polynomial trends that all of